So let's start this lecture with a little discussion on testability. Okay. When we work on most software, when we work on it, we really need to make sure that our code works correctly. And there are many ways to do that. One is to do manual testing. We on our game, we previously just did all that, right? We just ran our code and use our eyes to see if everything works, right? And we do some exploratory testing. We just test, okay, use our gut and try a way to test it. But it's really hard to do that like all the time, right? You cannot test all the functions all the time because it takes a lot of time, right? But another technique that you might have done a little bit from the previous course is unit testing. Okay, like in our class Maze, maybe you haven't wrote it, right, or you haven't written it, but yeah, there's a lot of function that you relied on, and they all can have bugs, so it's probably good to test them. Okay, but it's not that easy to test them. Okay, so let me show you why. Okay, first of all, to test stuff like this, you need to create. So we want to test classmates, and we want to test some of the functions, some of the methods. Okay, but first of all, you have to be able to create the object maze. If you look at the constructor for maze, you need to pass a game app. And we try to fake it by just passing none to it, but then it turns out that inside maze constructor, it tried to access the canvas game app.canvas. So you get an error. How are you gonna avoid this? One way to do that is to create a fake object. Okay, so this is one way to do that. Create a type from an object type, and then assign canvas to it, because we know that the problem is at gameapp.canvas. So we just assign a null to canvas, so that and then we pass it to app to maze. Turns out that yeah, you still get some error here. The error here, self.photo image. The problem is with photo image class from Tickle, TK Inter, because you have to create the frame before you can create photo image, probably. So you can see that it's not easy to test, because our maze class is tightly coupled with the UI element. Okay, so when we look at our game or any application that you write in the future, if you work with if your application has UI components, then you can roughly divide your work into two parts. One is the UI components, and the other is what we usually call domain models or domain classes. The domain classes or the domain models are the business logic, are the codes that that represent how things work in your system. And they are usually, if you look closely, it shouldn't be it can be decoupled from the UI in many ways. Like, for example, in our Pac-Man game, Maze and Pac-Man, and if you just throw away all the sprites or everything, it's just the domain code are just XY location of the Pac-Man and the Maze and everything like that. And if you currently, the Pac-Man locations and the Pac-Man sprite and everything are tightly coupled, so you cannot just run the Pac-Man without creating a TK frame. So that's make it really hard to test our code. Okay, so there are two approaches for this. If you want to do unit testing for our game, or mostly for UI applications, one is to monkey patch, to hide or fake or mock. You should remember the word mock, because we will use it again and again. So we do some patching so that we would hide all the UI dependency. The other way is that you would decouple all the UI and domain logic, so that you can run the game without any UI. In the project, in the second project that you will work on after this week, you will implement a game, ants and zombie. That in that game, the complete game logic has been decoupled from the UI, so you can run it on console, or you can run it on a UI. So that's how thing would be if you do that from the architectural point of view. Okay, we will look at both approach. So one way to, if you want to do the monkey patch, we can do something like this: create an object and a fake object. But yeah, but inside a fake object, maybe you would call another fake object, and it's gonna be really hard to do it manually or by ourselves. But luckily we have a library that help us doing that. Okay, so the way we do that is we would do something like this. So on a game app, instead of creating an object by ourselves, we would create something called a mock. Okay, a mock object. A mock object is we use mock libraries, and it's currently a standard Python library. Okay, so this mock object is gonna be a fake object that respond to any request. You can call any function on it. You can ask for anything from it. It will just fake it. Whatever you want from it, it will try to accommodate what you want. Okay, and you can so this fake object can be used anywhere. Okay, and then when you completely run your code, you can later on check if the interaction between your code and the mock object works according to the thing that you want. So we will create two mock objects. One is for the game app. Another is we will mock the whole class photo image here, so that when sprite try to do something with photo image, it will go through. Okay, but nothing would happen. Okay, so that's the idea. Okay, so let's take a look for 1 minute on the library. So the library is unit test mock. So this is the standard Python library. So let me show you how this thing works in console for really quickly before we move on to see the real code. So let's try to do something with the mock. So it's we used magic mock. Okay, so if you want to have some object, we just create a magic mock, and then with this magic mock you can do anything with it. Just request it, and we can say run. It would do something. A.h. Yeah. Okay, so you can set parameters. You can create something car dot drive itself. It would when you call a.car, it would create another mock object for you, and then you can call anything on the thing itself, and what it returns you can call other things like drive fast. Okay, so it's just this magic mock is gonna be extremely flexible object that you can do anything with. Okay, and then you can say if you want to assert, then have you call a. No, you don't, you haven't called a, but have you call run? Yeah, that's true. Okay. Okay. You can check if a.car.drive is called. You check how many times it is called count. Oh no. You can look at the method that you can assert many things, right? It can be called many times. Check the like call count. How many times this call? What once? If we call it again, call count is 2. So the theory of mock object is that when you do the test with mock, you investigate you make sure that your object, the object under test, the object under test actually interact with the mock object in the way that you would like it to be. Okay, but here we will not do so many assertion like that. We just use mock object so that we would hide all the dependency on the UI so that we can pretty much test the maze class. Okay, so this is what we want to do. Okay, so to test a maze class, we would create a new file called, typically we would have another directory called test so that we can test stuff, but here we would say maze test. Test maze. Okay. Okay, so let it import unit test, and then from test.mock import magic mock. Let's see how we're gonna use it. So I'm gonna use unit test for writing tests. You've seen doc test before, right? It's easy to use, extremely easy to use. But for unit test, you can do more complex thing. You can create stuff and then write code in many ways. Okay, so all right. So to do that, I'm gonna go over a thing really quickly so that you get some idea. For the practice, we'll work on the practice in the lab section. Okay, or maybe this is just for something that it might be useful later. Okay, so you create a class for the test. Okay, we want to test maze test, right? It should be subclass of unit test case. Okay, so let me. Okay, and currently we don't have any tests, so but we can try to run it. We call Python test and then pass the name of the file and say run 0 test. To run a test, we need to create a method that start with test. Okay, method with it's not gonna run all the method. Okay, let's say method run, it doesn't do anything. Okay, it would run method that start with test like this. Here it say run 1 test and it doesn't see any problem. So okay, so here let's look at maze. Let's test something interesting. Okay, so the really good we want to be able to test its movable direction. Okay, so in its movable direction, you pass the row column and the direction that you want to go. Okay, so if we here, so this is row column 1, and if you want to move up, you cannot do that. If you want to move left, you cannot do that, but you should be able to move down and right. So that's something that we would try to test. Okay, so first of all, to test that, you need to create a mesh. So we can just say mesh, but then again we run into a problem, right? So so let's do this from mesh import. You cannot just pass now, right? And then it would crash, right? So let's run it. You see some error because it doesn't have any canvas, right? So you need to pass an game app, right? So how you gonna get a game app? You can basically do this. Go magic mock, create a mock, and then pass it. Now everything related to game app is okay now, but still you have a problem with tk.photoimage, right? So to deal with that, we need to mock tk photo image as well. Okay, so it's not that easy, okay, but we can try. So we would import from tk import import tk inter as tk, and then we would say tk dot photo image equal magic mock. So we just mock the entire class. Okay, now you can run. Okay, see that mesh would create a dot, and a dot would create a bunch of photo image. Okay, so you can print tk dot photo image dot call count. Maybe it's been called like 260 times, right? So by dot, right, and walls and everything, but yeah, it just pretend that nothing happened, right? So this is how you're gonna mock stuff. Okay, and then you can check, right? You can do you can make an assertion. So with unit test, you can assert. You use self. If you inherit from test case, you have self.assert, a bunch of assert, right? So you want to assert equal, then mesh dot is movable direction 0 0, oh no, 1 1 and up, right? So we would have to import from the constant import star. Okay, and then we want to make sure that if you want to move up, right, the up, right, should be false. Let's try to see for 4 direction. Up, down, left, right. Let's say all false, it should crash, right? Say false, true is not equal to false. So you can move down, right? And you can also move right. And our test pass. So you can check it's movable in direction, right? And you can do many other things, right? Okay, so maybe you want to check something else. Let's see another thing as an example. So you want to make sure that you want to eat dot, right? Eat dot. Okay, so so we want to test eat dot, test eat dot. Okay, but now again you need to set up the mesh. You might want to copy something like that and then say cell assert true. You can just call assert true. Okay, has.add 1 1, right? So 1 1 should have some dot, right? And then we would say mesh dot eat. What is the method? Eat dot add mesh dot eat dot add 1 1, and then we wanna assert false. Sales dot assert false. Okay. See, let's see if it works. Now run 2 tests. Okay, so you check eat dot and has dot and eat dot, right? Now the crazy thing is that you need to do this in all the tests, right? You want to initialize all the mesh. So with this you can have this function setup. This function setup is going to be called every time before you start running the code. So before you run any test case, so you can do something like self. You can initialize stuff like that. Self.mesh equal self.app, and now you have self.mesh. So you can say self.mesh. So you don't have to initialize every time. Okay. Here, let me change this to assert false. It's more direct this way. So it's going to be assert true, assert false, assert true. So we check if this is this function return false and true. Again, here we have self.mesh, then self.mesh. So let's run. Okay, it looks fine now. Okay. All right. Before we finish this, let me show you another thing. Okay, you can do some patching. Okay, like tk.photoimage. If you do this and later on this tk.photoimage class is going to be the magic class forever after you run this. Okay, and this is maybe bad because maybe later on in your test we want to use photo image again. So the way to do that is to patch it instead. So you call method patch. So this is from mock again. So you say you want to patch tk inter dot photo. So you need to refer to this this class, this module directly, okay? And then you can just leave this out, I think. Let's see. Okay, and it would give you the class. Okay, but you can just ignore it. Okay, so this say you would mock this class, okay, and this class is going to be passed to you here, mock photo image, when the function is called. Okay, and you might want to use it, or maybe you don't want to use it. Okay, but you have it. Okay, this mock photo image, you can say, you can save it. So that you can look at it later on, like here. Let's print call. How many times this call? Like 260, right? But you can just ignore it. Okay. So this say patch mean you create a mock object to replace that thing, that class, and the mock class is going to be passed to you here. Okay, if you're gonna mock many things, you can do a lot of patches, but it's going to be applied inside out. Okay, and the order of parameters is going to be inside out, so this one goes to the last parameters, say something like that. Okay, but this is the details, but you can actually do this in Python pretty easily. So so if you want to do monkey patch so that you can test your code to hide all the dependency on the UI, you can definitely try to use this mock object. It's standard library in Python after Python 3.3 or something. Okay, all right, so it's really magical thing that you have this. Okay, in other languages you need to use some other mocking library, but in Python they have it for you. Okay, and probably this is the first time you see unit test. So basically you write some code and you assert it here like this, and when you want to run, okay, when you write a test that inherit from unit test.test case, the method that you want to run should start with test, and when you want to run it, the simplest way is to just call Python unit test and pass the name of the test. You can have a more advanced runners that try to find all the test cases you have, but this is simple enough to run. Okay, all right, this is one way to do the test with the UI component by doing some monkey patch. Okay, another technique, a more probably the better one if you want to start from scratch. Okay, is that you would decouple the domain codes and the UI code. So the domain class should be like UI free, should be like pure Python, and all the objects here is like pure Python object that has no dependency on any other thing, doesn't use any network, and then everything it's just a pure Python. Okay, doesn't have any UI and anything, and you want to make sure that this is runnable on its own. Okay, so you can test everything inside this without having to invoke the UI, and then you write the UI classes that basically wrap up everything inside again. So this is usually called the domain classes or the business domain classes. Okay, so this is like the logic of your code, how things works, and this should be if you can decouple the whole thing from the UI, then this is going to be extremely testable. Okay, because the UI is usually hard to test. We might look into this later on, but this is the idea. Okay, either you monkey patch to hide the UI, or either you can design everything so that it's UI free from the beginning, and then you just write the UI to works on it. So this is how the N and some B code looks like. Okay, so that's the next project that you work on. It has a UI component. You can run the UI and you can run the whole thing on the command line. This is true for Hawk, your previous project as well. You have a UI version, right? But the UI version just run your non-UI, your domain classes indirectly, right? So you can run everything on command line and you can use the UI. So with the command line code, you can easily test because you use the OK test, right? So this is true for the project on the second project as well. Okay.
So I would like to talk a little bit about two methods for performing unit testing. Okay, basically there are two ways to verify that your unit that you are currently testing is working correctly. One is called state testing. So basically you do something with the object, and then you check its states to see if it's finally the state change in the way that you would like it to be. Like for example, when we write test eat dot, we first check if the state of this hash dot at 1, right? We check if this is true, right? That the maze has a dot at this location, and then we call eat dot at 1 and then we check if the state at if at this location the dot is still there, and we check it shouldn't be there. Okay, this is like the state testing. You look at the state of the maze, like at that position the state is like there's a dot or there's not a dot, right? So you check the state. So this is called state testing. When you do this, sometimes it's really your testing code depends on how the object keep its states, not how you interact with the object. So maybe it's not gonna be a good way. Like your test might be too brittle. Like you change something on the object and then your test breaks, and that's then you need to fix your test case. So that's gonna take a long time to keep to maintain the test case and also your code, right? Okay, so another way is called interaction testing. So basically you're not gonna look at the state of the object, but you look at how objects the object that you want to test interact with the other objects, and if it interact in the way that you prefer or you program it that way, and that's how you see if it's work correctly or not. Okay, you're not looking at its state, but you're looking at how it interacts with other objects. For example, if you want to check if the update of Pac-Man is correct, then we first look at this class Pac-Man, and we see, okay, this Pac-Man class, what are the other objects that this Pac-Man interacts with? Okay, so basically with the maze, right? It call p center at the maze, and when you call update, we want to make sure that if there's a dot at this location, then the Pac-Man should eat the dot. Okay, so we would expect that when the Pac-Man call is at center, it return yes, and it gets the location and it call hash dot at, and then it should call eat dot. So this is like something that we would like to check if the Pac-Man actually works the way we like. Okay, you can do that with mock. Okay, with mock objects. Basically the idea is that you look at the object that you are currently testing. We usually refer to that as a cut, so component under test, and you see that this component interact with other components, like in this case component 1, 2, and 3. You can write a unit test in such a way that you don't even need to look at, you don't even have to need, you're not gonna need component 1, 2, and 3. All these components are just the mock object, and then you just check if this object alone, if this cut alone works the way you would like as specified or not. So that's how you're gonna use mock object. So this is the key reason for mock object. Okay, so let's take a look at this example. Suppose we would like to see if the Pac-Man would eat a dot, okay, when the maze return hash dot at. Okay, suppose we would like to do that, we would have to mock without having to implement maze. Okay, we can just throw the maze away, we just don't have it, but we can mock everything. We can say, okay, when the Pac-Man asks piece center, you should return this, a mock should do that, and then you pre-program the mock maze object without having to write or implement the actual maze. You can check if Pac-Man works the way you would like it to be. Okay, so let's see some example. Okay, so before that, let me show you how mocks work a little bit more. Okay, so from unit test.mock import magic mock. let's say a equals magic mock. So suppose this is the magic mock. You can program it so that when you call a, we say return value equals 10. Then we call a, we get 10. So this is like you pre-program the mock function. Okay, say suppose you have a dog. Okay, and you want this dog. Now if you just call dog dot run, it would just won't do anything, right? It just pretend that it can do anything, but it doesn't actually do anything. But you can say you can pre-program doc.run so that when you call doc.run, the mock would return a value, like return yes, something like that. Hello. สวัสดีครับครับอ๋อครับครับครับ You can program that doc.run would return yes. So let's do that. It will return yes. So you can pre-program anything with magic mock. Okay, this is what we're gonna do to test the Pac-Man class. Okay, we use return value like that. Okay, all right, so let's look at the code. Okay, we want to test we first need to create a Pac-Man, right? So we import Pac-Man and then test eat dot. Okay, and then we say Pac-Man dot update. So we're gonna call update on the Pac-Man, and we would like to see if the maze, the Pac-Man called eat dot or not, right? So basically you would come back, look at the spec, not just the code. Okay, you need to look at the specification on how the Pac-Man would work. First it should call is at center, and then it should call all this, and then blah blah blah. Okay, so let's look at it's suppose we look at the specification and we get to see this code. Normally you're not gonna see this code, but let's say we know the specification, so let me copy it here a little bit so that we know what. Okay, so it would call maze at, so let's create a Pac-Man class first. Let's say a Pac-Man. Say we want to test many things, so let's use setup. So self dot Pac-Man equals Pac-Man. You want to create a Pac-Man class, right? But the Pac-Man class, what should go into? You need an app, a maze, and R and C, right? So so we okay, so we would use, we create a magic mock and of an app, a magic mock of a maze. So we can say Pac-Man put location 1 1 like that. Okay, and also recall that Pac-Man also need to use TK photo image. So we would do like in test maze, right? So we would patch it like that, exactly like that. Okay, so we would patch with the photo image. Okay, so from unit test mock import magic mock and patch. Okay, so now you can create a Pac-Man. Okay, so let's see if you can run it. So I would comment it out so that you can test the code. So Python -m unit test and then test Pac-Man. Okay, doesn't know app, self.app self.net. Okay, so Now there's an error here. Okay, not enough value to unpack. So this is when you call pacman. If you look at the code, and pacman would call piece center RC, right? But the maze in our code, the maze is just a mock, so it doesn't know how to react into anything, so it won't return anything much. So we need to program it. Okay, piece center, and then we say it should return value equals, say, anything, 20. So this is the location of the pacman. We can return anything we like. Okay, it should be okay now. Okay, so, and then it also call xy to rc. So this is the code here, and it would call is at center. Okay, so we need to pre-program all the interaction of the maze. So I say maze equals cell, so that my code is a little bit shorter. Maze xy to c, and then we would just say return value row column 1 1. Okay, and then it's at center, and it should, we want it to return true. Okay, and also hash.add return value equal true, and then we call cell.pacman.update, and then we assert true maze eat.add.call. So we check if the method eat.add has been called or not. Okay, so we can check it, say okay, it's called, and if we say this is false, if there's a dot, then you should assert that eat.add is not called, right? So we would write two test case: eat available dot. So when there's a dot, we eat it, right? When there's a dot, you eat it, and if there is no dot, you shouldn't eat it. Okay, eat no dot. Okay, so if return value is false, then it shouldn't call eat.add. Okay, so our test will look like that. Can run our test. You can see that it passed the test. This is nice in the way that our test, this pacman test, depends only on pacman class. Okay, you can see that we haven't include any maze class at all, because a maze is just a mock object that we pre-program. Okay, we completely pre-program it without actually looking at the maze function here, maze class here. So we can rename the maze class here, and our test would actually still run perfectly. Oh, okay. We import maze, right? Pacman would import maze, so so you need the maze class available. So, but you don't need the implementation, so you can say class maze like this, and it will run fine. Okay, so you can test pacman without having to worry if the maze class is correct or not, because you completely specify the behavior of classmate by yourself, right? Okay, so this is called interaction testing. Okay, with the mock, you use mock object to hide the actual maze class here, like this. You don't need the other class because you mock all of them, and you just check the interaction of your class with the other class that you have already mocked. Okay, so So this is the idea of unit testing that you might find useful later on when you wanna when you wanna actually test a unit that depends on other unit without actually having to change too many things, without having to wait for the other unit to be available or working. Okay. All right. So the first part of this lecture would be just that. So a quick review on unit testing. Okay. See you in the next clip.